Good day, viewers. You are welcome. Let's see how to solve this problem. I equals to integral from -2 to 2, 1 plus s squared all over 1 plus 2 raised to power x dx. Solution. By rewriting the problem, I equals to integral from -2 to 2, 1 plus s squared all over 1 plus 2 raised to power x dx. If you look at this problem, this is unlike our usual definite integral, but this is a special case in it, and we call this a symmetry type definite integral. So we can, by saying let f of x equals to 1 plus s squared all over 1 plus 2 raised to power x. Using the property of a definite integral of minus a to a f of x dx. This will result to integral from minus a to a f of minus x dx. Now let our f of minus x will now be equals to 1 plus s squared all over 1 plus 2 raised to power minus x. By adding the two together, by adding f of x and f of minus x together, that the result will be 2i, I plus I, that is 2i equals to integral from -2 to 2 f of x plus f of minus x dx. Now, what will be the result of f of x plus f of minus x? F of x plus f of minus x will be, because we said let f of x to be 1 plus s squared all over 1 plus 2 raised to power x plus f of minus x, that's what 1 plus s squared all over 1 plus 2 raised to power minus x. If you can see the two, we have a common factor which is 1 plus s squared. So this will be equals to, if you factorize it out, 1 plus s squared here will be 1 over 1 plus 2 raised to power of x plus 1 over 1 plus 2 raised to power minus x. I factorize out 1 plus s squared. So from here we can just say let t equals to 2 raised to power of x. Therefore, from here we can say f of x plus f of minus x equals to, here I have 1 plus s squared, open and close the bracket. This is, now here we have 1 over 1 plus 2 raised to power of x, we replace it by t, 1 plus t plus 1 over 1 plus 1 over t. And this one will be equals to 1 plus s squared will be equals to 1 over t over 1 plus t plus t over 1 plus t, which is equals to 1 plus s squared, open and close the bracket. If we make the LCM 1 plus t this will go in this one, so 1 plus t multiplied by 1 plus t, that is 1 plus This will goes in this one times t as well, which is equals to 1 plus s squared, open and close the bracket, 1 plus t over 1 plus t. This will go result as 1. Therefore, f of x plus f of minus x equals to 1 plus s squared. So if f of x plus f of minus x equals to 1 plus s squared, so we now have 2I equals to integral of from minus 2 to 2. Instead of f of addition of this, we now substitute the answer, which is 1 plus s squared dx. 2I will now be equals to, if we split the functions into 2, integral from minus 2 to 2, 1 dx plus integral from minus 2 to 2 s squared dx. So let's integrate. You can just add 2I equals to, if you integrate 1 dx, this will give us x, introducing the limit minus 2 to 2, plus integral of s squared. This will give us x raised to the power 3 over 3 minus 2 to 2, plus c, which is an arbitrary constant, minus 2 to 2. 2I will now be equals to, by substituting these values, whenever x is 2, this will give us 2. Whenever x is minus 2, this is minus, open brackets, minus 2, plus whenever x is 2 here as well, that is 2 raised to the power of 3, and that is 8 over 3 plus, plus 8 as well. That is whenever x is minus 2 raised to the power of 3 all over 3. Let's add 2I will be equals to 2 minus as minus, that is plus 2 plus 2 will give us 4, plus 8 plus 8, that is 16 over 3. By taking out the LCM, which is 3, 2I will be equals to 3. This one is over 1. 1 in 3, 3 times 4, that is 12, plus 3 in 3, that is 1. 1 times 16, that is 16. 2I will be equals to 12 plus 16, that is 28 over 3. By crossing multiply, this is 2I, that is 3 dot 2I equals to 28, and 3 times 2 will give us 6I equals to 28. We have to look for the value of I. If I multiply by 6, therefore I will be equals to 2 here, that is 14, 2 here, that is 3, and the final answer is I is equals to 14 over 3. Don't forget to subscribe to my channel. See you in the next video.